The difference between what we did on Friday and what we're doing today is very little. The difference is I've got bounds. Okay, when we treat U-substitution problems with bounds, we have to approach it a little bit differently. Okay, there's two different ways of doing this problem, both of them pretty similar. They're very similar to what we did on Friday. I'm going to teach you it one way specifically because it will help you on an AP question that they ask. They always ask this AP question the same way, like the one on the bottom of this paper. So if we set it up the way that I'm teaching you here, it'll just make it easier when we see that problem. All right, we look at this problem. We've got 0 to pi over 4, tangent x, secant squared x. This is going to be a U substitution problem. I can tell that mostly because I see multiple x's in there. Use your brain. Think about it. Talk with your neighbor. What do you think your U is going to be? Anybody have a guess as to what they think U is going to be? It is not secant squared. It is tangent x. Jesse, why do you think it's going to be tangent x here? We picked tangent because when he took the derivative here, if we did du over dx, the derivative of that is secant squared. And then when we get dx by itself, that when I substitute back in is going to cancel out the other thing. Normally, 98% of the time, it's the thing with the bigger exponent. But not in this case, because the derivative of tangent is secant squared. A little bit different. It's a good thing to use your brain on. Questions there? Nice. Once we've done that, that's important. But the next thing we got to do is mess with our bounds. Okay, we are going to change our bounds. We are going to change the problem to U. We also need to change the bounds to be in terms of U as well. All right, so that's the difference between what we did before and now. So what we're going to do is we're going to take these bounds and we are going to plug them in to whatever we said U was going to be. So we're taking pi over 4 and we're going to take tangent of pi over 4. What is tangent of pi over 4 going to get me? It is 1. Think about where pi over 4 would fall in the unit circle. It would fall right there. You get this ordered pair right here. We do y over x, radical 2 over radical 2. The answer is 1. That's my new upper bound. That's this upper bound, but once I've plugged it into U. We're going to do the same thing with the lower bound. I'm going to take 0 and plug it in. What is tangent at 0 going to be? What is y over x right there? Y over x. What's it going to get me? 0. Okay. So we look at this problem. We identify it's a U sub problem. We change it in terms of U. We also change our bounds in terms of U. And that's the big difference between what we learned on Friday and what we're doing today. We're going to set it back up. We're going to substitute in everything. It's not going to be in terms of x anymore. My lower bound is going to be 0. My upper bound is going to be 1. I'm not going to write tangent of x. Instead of tangent x, I'm going to put the letter U. Secant squared x. Sure, that's fine for right now. And then I'm going to substitute in for dx. For dx, I'm substituting in du over secant squared x. If I did it correctly, all of the x's are going to cancel. Did that happen here? Yeah, again, that's why we picked tangent. Because now those two things are going to cancel out. And I'm left with the simple integral from 0 to 1 u du. Now everything in this problem is in terms of u. I don't care about the letter x anymore. I never have to go back to letter x because I changed my bounds as well. So then we're going to do it. We're taking the antiderivative of u. Evan, what's the antiderivative of u going to get me? No, antiderivative of u. I'm adding 1 to my exponent.
Half u to the second.
Yep, good. 1/2 u squared. And we would put plus c, but I'm not going to put plus c here. What am I going to do instead? Plug it in. I'm plugging in my balance. Okay. I'm plugging in. I'm going to plug in 1. I'm going to plug in 0, and I'm going to subtract the two things. Okay. If I have a constant, I always like taking the constant out because it makes the problem easier. So I'm going to take the 1/2 out. I'm going to do 1 squared minus 0 squared. I'm plugging in the upper bound, plugging in the lower bound, and subtracting the two. 1 squared is 1, minus 0 is 0. 1/2 times 1, my answer. is 1/2. A little bit funky, but it's just a matter of saying, all right, we're doing U substitution. The only difference is we're changing the bounds. And normally when we change the bounds, it makes the problem easy at the end. And normally some pretty simple math towards the end. Questions on number 9? The answer is 1/2. Let's look at number 10. First thing we're going to do is figure out our U. Don't let the last problem cloud your vision as to what you think the U is going to be. Remember, if it's cosine squared like that, that is the same thing as cosine squared like that is the same thing. What do you think my U is going to be? Nah, it is cosine x. It is cosine x because the derivative of cosine is sine and it's being squared. Okay, there's no other way of getting rid of the square if I don't make it cosine. It's different than the last one because it just happened to be that the derivative of tangent is secant squared. Don't let that other one throw you off. Go ahead, find what dx is and find your new upper and lower bounds. Talk with your neighbor. Go. Here we go, du dx. Again, some of you were concerned that I made this my u. Well, the derivative of cosine is negative sine, which is weird, but negative is a constant. Okay, so it doesn't change anything when I go back to cancel. Okay, when I solve this thing, it's du over negative sine x equals dx. To find my upper bound, remember, all you're doing is you're taking this value and plugging it in. What is cosine at pi going to get me? That is -1. I'm going to take 0 and plug it in. What is cosine over there at 0 going to get me? +1. It's the x values. So if I look at cosine, it's the x values. That's where I'm getting -1 and 1. Issues to that point? I haven't messed with the square yet. The square has not been affected yet. So we set it up. Lower bound is 1. Upper bound is -1. It is u. I've still got the square. Sine x. And instead of dx, I'm going to plug in du over negative sine x. If I did it correctly, again, this is why we picked what we had, the things are going to cancel. Do my x's cancel? Yeah, that sine x and that sine x are going to cancel. Do I have any constants? That negative sign. That negative sign, that's just a constant. We could throw that out in front. Okay? What else do you notice about this problem as you set it up? Yeah, we don't like the bounds right now. My lower bound is on, or my smaller bound is on top. I don't like that. So I can flip my bounds and make it -1 to 1. If I do that, what else do I have to do, though? Change the sign. So I'm really changing it twice. The first time I changed it because I took this negative and put it out in front. The second time is because I flipped the bound. So it's really going to be a positive integral after all that. U squared du. Then we go ahead and integrate. The antiderivative of u squared is going to get me u cubed. Divide by my new exponent, 1/3. Evaluate that thing from the lower bound to the upper bound, -1 to 1. I've got a constant, so I like just taking that constant out in front. It's 1 cubed minus -1 cubed. What is 1 cubed minus -1 cubed going to get me? That is 2, because -1 cubed would be -1 minus a -1. That is 2 times 1/3. My answer is going to be 2/3. Questions on 10? Let's go to 11. Okay, same idea. On number 11, we're integrating from 0 to 2. X squared, square root of x cubed plus 1. Tell your neighbor what you think u is going to be. Right, here we go. We got to identify the... In this problem right here, it is x cubed plus 1. Again, a couple reasons for that. One of them, it's inside of parentheses. It's underneath that square root. The other reason is because what is the derivative of x cubed plus 1? 3x squared, and that x squared right there and that x squared are going to cancel. We set that up. We get dx by itself. We get to that point right there. The other thing I have to do is change my upper and lower bound. Show me with your fingers, what is your upper bound now going to be? Upper bound is now 9 because I'm taking 2 and plugging it in. 2 cubed plus 1. So 8 plus 1 gets me 9. Lower bound, 1. We're integrating. We are going from 1 to 9. We've got this x squared here still for now. Hopefully we get rid of it if we're doing it right. It's u. I had to, is the rule. Sorry, it died. U to the 1/2 power. And then we've got to plug in for this guy, which is du. Nah, I'm just going to do it just to annoy you. Over 3x squared. There's my setup. Oh, it definitely annoys me. Definitely annoys me. If we did it right, we can cancel stuff out. Aiden, what can I cancel out? Aiden B. X squared's cancel. What else can I do? Pull 1/3 out in front. So I've got 1/3 integral from 1 to 9, u to the 1/2 du. Try and integrate that real quick with your neighbor. We are antiderivative here. So if I'm taking the antiderivative Slade, what's my new exponent going to be? 3/2. What else do I need to do? Yeah. Multiply in front. What am I going to multiply by? The reciprocal. So he's multiplying by 2/3. So his new bound is 2, or his new constant is 2/9. He's evaluating that thing from 1 to 9. So some of you get a little anxious about this. Don't be. Okay. The 2/9 hangs out in front. I'm taking 9 to the 3/2 minus 1 to the 3/2. 9 to the 3/2 power is not scary. It's the number one thing that my students just freak out on when they're doing multiple choice. What does the 2 on bottom mean? Square root it. What's the square root of 9? 3. And then that's 3 cubed, which is going to get me 27. This to the 3/2 power is just 1. I'm multiplying that all by 2/9. 26 times 2 is 52/9. Questions there? All right, let's go to example 12. Example 12 is a classic problem that it looks really funky, but it's not hard at all. Okay, it looks really hard, and so at first glance, you're like, I can't do that. But then once you've looked at it for at any time, it's pretty easy. We look at this problem. What makes you think that this is a U-substitution problem? Parentheses. I've got an X with something else inside of parentheses. It is a U-substitution problem. Okay, so my U is going to be 2x. Oh no, they didn't tell me what the function was. Who cares? Just do it. Okay, my U is 2x. Figure out what du over dx is. Figure out what du by itself, or what dx by itself is. Find your new upper and lower bounds. Go. Luke L, what's my derivative going to be? 2. So when you got dx by itself, what'd it get you? Du over 2. New upper bound? 6. New lower bound? 0. He's just taking 3 and plugging in, taking 0 and plugging it in. Great. It looks weird. Again, I don't care that it looks weird. We just do it anyways. Okay? My lower bound is 0. My upper bound is 6. F is still there. But it's not going to be of 2x anymore. Now it's going to be f of u. Instead of dx, we can substitute in what dx is. Du over 2. Do I have any constants? 1/2, so I can pull it out in front. And then just do the problem. I'm integrating f of u, lowercase. What comes before lowercase f of u? Capital F of u. Is it weird? Sure it is. Doesn't matter. Okay, that would be my setup. Then all I would have to do is evaluate it from 0 to 6. So I have a constant. Plug in the upper bound. Plug in the lower bound. That's my answer. Now, we probably would need more information to go somewhere else. Maybe it's multiple choice. Maybe it's something else. But for right now, that's as far as I can go because I don't know what F is. And so if I don't know what F is, then I can't go any further. Makes sense on what we were doing? It's the principle of what we did before, just without a weird function at the end. The number one probably AP exam's favorite question about U-substitution is this one down below. All right. So it says using the substitution U equals sine 2x. So they are telling you what U is. They didn't make you think. U equals sine of 2x. Here is the problem that you're going to use U substitution with. You are trying to figure out which of these answers is the same as this guy right here once you've plugged in what U is. Use your brain for a second. Talk with your neighbor. See if you can figure your way out. Show me an answer once you get it. A, B, C, D, or E. Go and finish all the way here. That's U. We need to figure out du over dx. What do I need here to take the derivative of sine of 2x? Chain rule. The derivative of sine is cosine. We would rewrite the baby, and then I would also have to include the derivative of the baby. So I'd include a 2 there, because the derivative of 2x would get me 2. Everybody with me to here? So it's du over 2 cosine 2x equals dx. The other thing I need to do is change my upper and lower bounds. So weird, but I'm plugging in pi over 2 into this thing right here. So it's 2 times pi over 2. What's 2 times pi over 2 going to get me? Pi. What is sine of pi going to get me? Sine of pi would get me 0. Then I would take pi over 6 and plug it in. Pi over 6 times 2 is pi over 3. Think about on a unit circle. Pi over 3 is this guy right here. It is this ordered pair, 1/2, comma, radical 3 over 2. What is sine at pi over 3 going to get me? Square root of 3 over 2. And you can kind of see that by the multiple choice answers. That would be helpful to you. Everybody with me to that point? Then we do some substitution. We are integrating from square root of 3 over 2 to 0. Instead of sine of 2x, I'm going to put a u to the 5th power. Okay, then I've got this cosine of 2x still. And instead of dx, I'm going to put in what dx is, which is this du over 2 cosine 2x. If I did it right, there shouldn't be any x's anymore. Did I do it right? Cosine 2x, cosine 2x. Any constants? I got a 1/2 right here that I could pull out in front. From there, I can say what my answer is. What's my answer going to be? A, B, C, D, or E? It is D. They didn't flip the bounds. I would say normally they do, but here they didn't. So it's D. It's equivalent. It's not saying that's the right answer. It's just an equivalent setup. Make sense on what we did there? It's just what we normally would do. They just like to leave it in multiple choice form. All right. Last thing of the day here. Okay. This is supposed to be easy. It takes some time to get it figured out. We'll practice this again tomorrow. Okay. But indefinite integral formulas. Okay. These are rules that apply all the time. We are going to use mental Usub. Mental Usub to do these problems. All right. Let's try that. Let's look at letter A. I'm going to make it a little bit easier for us so our brains don't hurt on the first one. Let's make it cosine 3x. Okay, cosine of 3x. If I am doing mental Usub, okay, thinking about what we would do here, if we were to do Usub, we're going to get to the point where you don't need to do Usub on this problem. You could just do it in your brain. What would you think the U is going to be? 3x. Okay, we could do the whole thing. U is 3x, so du over dx is 3. So du over 3 is equal to dx. Everybody with me on that? So if I set this up, it'd be cosine of u, and then instead of dx, I could put du over 3 right there. What's the antiderivative of cosine? sine. We could rewrite the baby, but what else would I need to include here? What else would be included in my answer? This 1/3 and the plus c. All right, so mental U-sub tells me this. If I've got this thing right here, and your u is just going to have a constant in it, just take the antiderivative. What's the antiderivative of cosine of 3x? It's sine of 3x. And then divide by the derivative of the baby. We divide by the derivative of the baby. It's mental U-sub. It's kind of like a quick chain rule kind of concept. All right, let's try another one. Let's go to letter D. Okay, looking at letter D. I'm jumping around here because I'm trying to find problems that are similar to what we want to do. Okay, letter D. What would you make your u be here? What would your u be for this problem? What? 2x. We're jumping around. We're on letter D. We're on letter D. Stay with me. It's 2x. All right. Since my u is going to be just an x and a constant, I can do mental U-sub. All right. So what is the 1/4 is a constant, so that's hanging out. What is the antiderivative of e? E. So the antiderivative of e is just e. But I would also need to divide by the derivative of my u. So what else would I need to include here? 1/2. My answer is 1/8 e to the 2x plus c. If you don't believe me, you could do a full-blown U-sub problem. But that is my answer. I did multiply by 2. I divided by the derivative of it. Because think about it. Because it'd be du over dx, which would be 2. And then it'd be du over 2 equals dx. That 2 goes on bottom. That's why this is going on bottom.
Did you take the derivative of e?
No, I didn't need to. I'm doing the antiderivative. Let's try it again. Try letter E real quick with your neighbors. See if you can figure out what E is going to be. You can do E and F real quick. Try E and F. Try to do mental U-sub. See what you get. When I look at E, again, since my U would just be a constant, we can just take the antiderivative of sine. What is the antiderivative of sine? Cosine, negative cosine. We could rewrite that baby, and then we would divide by the derivative of the baby. So what else would I need here? 1/3 plus c. On letter F, we look at the problem. We identify our u. Oh, it's a constant. Okay, it's just x and a constant. So since that's true, we just take the antiderivative. 6 is a constant. The antiderivative of e is just going to be the same thing. And then I'm going to divide by the derivative of my u. So what else would I need to include here? 1/4 or 6 over 4. That's why it's 3/2 e to the 4x plus c. You can always do long U-substitution, but this mental U-sub idea is going to be helpful as well. Okay, save you a whole bunch of time, especially on a long problem. Questions on F? We're going back. We're not done yet. Let's look at B, because B is important as well. Let's do it the long way. What would my U be? The bottom, x plus 2. What would the derivative of x plus 2 be? It's just 1. Okay? This would just be 1, and we could do this whole thing, du equals dx, and so on. So what I get here, do I have any constants? 3, pull it out in front. And then it would be 1 over u du. What is the antiderivative of 1 over u? Natural log, absolute values. I still got that 3 out in front. Plus c. And then in place of that would be x plus 2. This is just something you'll recognize. When you have x to the first power on bottom, x to the first power on bottom, recognize that, hey, that is a natural log problem. X to the first power. If it's more than just x to the first power, it's not natural log. Okay, with that same thing in mind, let's look at letter C. We got a constant, it's 2. What is the antiderivative of 1 over 5 minus x going to be? What do you think? Natural log. Absolute value, 5 minus x plus c. But that's not it. We are going to include a negative as well. Why is that?
Negative.
Yeah, because think about it. If I took the derivative here, I'm going to get a negative 1, and so I would have to substitute back in a negative 1. This is my answer. You don't have to be perfect at mental use substitution. If that blows your mind, then don't worry about it. Just do it the long way. It'll go just as fine. But if you get to the point where you can recognize that, hey, my U is pretty straightforward, it's going to make things a lot easier in the long run. Questions with that? Now, remember,